Hello everyone, we are going to evaluate this limit in this video. So we can't right away evaluate this limit since there is an absolute value function. First of all, we should recall what is an absolute value function. Recall absolute value function. People, absolute value function is a piecewise function. It is defined as is equal to, let's say, f of x is equal to absolute value of x, that is equal to x whenever if if x is greater than or equal to 0, and it is equal to minus x if x is less than 0. So this is what absolute function means. Okay, let's keep this aside. So here we need to know what is x plus 6, absolute value of x plus 6, that is equal to x plus 6 if x plus 6 is greater than or equal to 0, which means x is greater than or equal to minus 6, correct? And is or else is equal to minus x plus 6 if x plus 6 is equal to less than 0, which is if x is equal to less than minus 6. Okay, so here since x is, let's say, suppose this is the x axis and here minus 6, here minus 6 is here. Now we are going to use the left hand limit and right hand limit to solve this question. Okay, whenever x is of the in the left side of minus 6, it is less than minus 6. So this part of the function we will be getting x plus 6, and whenever x is greater than minus 6, it will be x plus 6. Okay, now we're going to evaluate the limit from this side, from the right hand side, and from the left hand side. Okay, and separately we are going to evaluate the limit, and then we are going to compare those values. If it is same, the limit exists, and the whatever the limit that comes is the limit. If the limits are different, then there is the limit does not exist. Okay, so here now we're going to take the limit. So let me change the color. The limit whenever x goes to minus 6 to x, let me get the left hand limit. Okay, left hand, that is equal to minus x plus 6. Let me write it clearly. X plus 6. Okay, so that is equal to, we can take the 2 common factor out, that is x plus 6, here minus x plus 6. We can cut this off, and that will yield us minus 2, correct? Now we are going to evaluate the limit from the right side. Right side is positive. Okay, that is equal to x plus 6. That is equal to 2. Again we are taking the common factor 2 out, and x plus 6. So we can cut this off, and that will yield us 2, correct? So the right hand limit is not equal to the left hand limit. Thus, the limit whenever x goes to minus 6 to x plus 12 over z equal to of x plus 6 does not exist. Why? The limit is different. If we are not sure about our answer, we can always sketch this graph. For sketching the graph, mostly I'm using Desmos website. You also can use this website and check this graph, or else you can use Wolfram Alpha. The Wolfram Alpha in Desmos a little bit clear. So Wolfram Alpha is more powerful than Desmos. Desmos is clear whenever you are going to graph like this simple function. Use Desmos. Desmos is better. You can check that this limit does not exist. Actually, the graph will look like it's minus 6. It will look like this. This is how the graph will look like. Plus 2 and minus 2. Okay. The graph is a discontinuous graph.